Hey everybody, welcome to section 1.5, graphing linear functions and inequalities. A lot of this today is going to be, I hope, bread and butter from what you might have learned in Algebra 1. So let's review. Some studentship tips. First of all, anytime they want to graph, you really got to go equation table graph. If you think you don't, it's still a very good habit to be in, and it'll serve you well to reinforce that habit today. So I want to see them tables. And I want you to show the work in the table. Make the tables large enough so that you can actually show the work and you can proofread it in a kind of a systemic, organized way. And lastly, write down knowns and unknowns for those word problems. Let me show you what I mean. So if you have f of x is equal to 3x minus 4 and you're asked to produce a graph, one really great way to do it is with a table. So you can choose, for this particular strategy, in this particular version, you can choose any x values you want. Let's choose 0, 1, and 2. And then you can see plugging in f0 is the input. Then what is the output? Well, f of 0 is going to be 3 times 0 minus 4. And that comes to negative 4. What about if the input is 1? The input is 1, then f of 1 is going to equal 3 times 1 minus 4, which is negative 1. What about if the input is 2? F of 2 is going to equal 3 times 2 minus 4, which is 2. You can plot all these points, 0, comma, negative 4 here, 1, comma, negative 1 here, 2, comma 2 right here, and then you can see they go right together in a straight line, and that's great. You might say, Mr. Bergman, wait a minute, do we really have to do 3 lines? Can't we just do 2? And my answer is yes, you could technically do 2. If you're in a quizzing situation, it's actually great to just do 3 just so that you get confirmation. Like if you get 3 collinear lines all straight together, then you know you did something right. If you only did 2, then you won't get confirmation. So just a studentship tip there. Sometimes you might see 3x minus 4 equals 12. It's in a different format. You see x's and y's, and they're both on the same side of the equation. There's a couple different ways of doing this. One way would be to focus on the x and y intercepts. So let's say you just chose x to be 0. That would cross out this, and you have negative 4y is equal to 12. And you could solve that. Dividing both sides by negative 4, you get negative 3. Working in the other direction, you could choose y to equal 0. 0 is a great number to plug into equations because everything just cancels out. This 4 times 0 cancels out, and you're left with just 3x is equal to 12. Dividing both sides by 3, you get x equals 4. Anyway, both of these rows represent the 2 different intercepts, the x-intercept and the y-intercept. And you can string them together, and that's how you get, that's just one more way to get a line on a graph. Next, here's another version of the same thing. Notice the format of these is both very similar. These are both in general form or standard form. And you have the x's and y's on one side, and you have a number on the right-hand side. So we could, if you wanted to, use x and y intercepts for this. But I think I'm going to show you a different strategy, and that is solve for y. If you wanted to solve for y and get it all by itself, maybe one thing to do would be to add 3y to both sides, just to get rid of the subtraction. So you have 12x equals 6 plus 3y. And then if you're trying to get y by itself, you could subtract 6 from both sides as well here. Last step to get y all by itself is divide all the terms on both sides by 3. 12x divided by 3 is 4x. 6 divided by 3 is 2. 3y divided by 3 is y. You can actually choose any number you want and divide all the terms on both sides by that number. And if you do that carefully enough, then you get y is equal to 4x minus 2. And that is a lot easier to work with on a table than this. So you could choose, like we did in the first example, you could choose your inputs 0, 1, 2, put them all here and calculate. So 4 times 0 is 0, minus 2 is negative 2. 4 times 1 is 4, minus 2 is 2. And I want you to tell me, what is 4 times 2 minus 2? What number is underneath this red dot? Anyway, each of these 3 lines represents these 3 points. Technically, geometrically, algebraically, you'd only really strictly have to do 2 if you were 100% sure you could do them both right. In a quizzing or testing situation, sometimes it's better to just go to the third step so that you feel really good about the calculations you've done, and they're all in a straight line. Over here, it might say to graph the line x equals negative 5. And x equals negative 5, you and I both know the x-axis is horizontal, but the line x equals negative 5 is vertical, and that's cause for a lot of confusion, honestly. It's difficult to remember that although the x-axis is horizontal, the line x equals -5 is vertical. So, but the reason it's vertical is because it represents all of the points that have an x-coordinate of -5. This is -5, comma 0. This is -5, comma 2. This is -5, comma 4. This is -5, comma 6, -5, comma 8, -5, comma 10. All of these points all have an x value of -5. So that's why it is the way it is. It's basically the line that is 5 units to the left, and we go to the left along the x-axis. So you can think of it this way. X equals -5. Well, let's go along x to -5 and draw a line. And then, very similar thing here. You've got y equals -2. And this is a collection of all the points that have a y-coordinate of -2. And you and I both know that the y-axis is vertical, but the line y equals -2 is horizontal. And that, like I said, in the same way, it is kind of tricky to remember that. But maybe we can think about it this way. It's the line that is 2 units down from the origin. 2 units down. All these points are 2 units down. So remember, vertical lines are graphed in the form like x equals 3 or x equals 6 or x equals 10. And horizontal lines are graphed in the form y equals 2. That's what I got. All right, y'all, pause the video, go grab that calculator, turn it on, charge it up, and when you come back, we'll get started. Boom, 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 boom. Now that you're back and you've got your calculator, let's rock and roll. So check this out. I'm going to show you how to use your calculator. You go press A, and you're going to type in the word solve. We're going to solve an equation, parentheses. And then let's say it's like, I don't know, 3x plus 9 is equal to 27, comma x, close parentheses. If you hit enter, it tells you what the answer is. X is equal to 6. It solved the equation. Type in solve again. You get 4x minus, I don't know, 2y is equal to 8. Solve it for what? Solve it for y, parentheses. And it solves it for y. It does the algebra for you. There it is. Isn't that crazy? It can solve equations. It can even rearrange equations. You just have to tell it what variable to solve for. And the top example, it solved for x, and x gave you a number. And in the bottom example, it solved for y, and it gave you an answer. There it is. Enjoy.